Hi, sixth grade. Welcome to chapter 17. We're going to switch gears and start talking about fresh water in this chapter, okay? So in the past, we talked about the fact that the earth is covered with about 71%, or 71% of the earth is covered with water. When you look at the planet as a whole, it's known as a water planet, okay? But most of that, so of that water, of that proportion of water covering the earth, 97% of it is salt water. It's ocean water or salty lakes, okay? So we can see 97% of the earth's water is actually salt. That leaves 3% being fresh water, and it's actually slightly less than 3%, okay? But of that, almost 2% of it is completely frozen in the icebergs or glaciers, okay? So not really accessible for drinking, okay? So we've got this thing known as groundwater. This is where most of our drinking water comes from, okay? So less than 1% of all of the water on the earth is like liquid fresh water, okay? 96% of our supply of drinking water comes from what's called groundwater. And groundwater is basically water that's under the ground. So we'll talk about how it gets there in a minute. But that's less than 1% of all the water on Earth, okay? So 97% of all the water is salt, less than 3% is fresh. Of that, almost 2% is frozen, 1% is either groundwater or like lakes and rivers and streams are part of that, 1%. You can see there's lakes, rivers, and then groundwater, okay? So our drinking supply of the world is 96% of it comes from groundwater. So let's talk more about groundwater. This is a big deal, though, because water is absolutely essential for life. You'll learn more about this in seventh grade, but people die of dehydration very quickly. There's a lot of waterborne illnesses that can be transported around through dirty water. We have clean water in our houses and we don't even give it a second thought. It's not like that all over the world, okay? Without that clean water and enough of it, it's a huge health risk and potential life and death situation, okay? So why don't we run out? If so little of our water is available fresh water to drink, less than 1% of all the water on Earth, why don't we run out? And it's because God gave us this thing known as the water cycle, okay? Water is considered a renewable resource simply because it's continually replenished in this water cycle. Okay, so you got the surface water down there. I'm kind of getting myself out of the way. And so you'll be able to see all these steps of the water cycle. Okay, the first step is evaporation. Okay, so off of that surface water that I just showed you down there, oceans, rivers, streams, surface of any kind of water, doesn't matter if it's salty or not, water evaporates, okay? So if you put a cup of salt water out on the counter, the H2O is mixed with NaCl, that's salt, okay? The surface of the water, that liquid water can turn into a gas, and it's still just H2O, okay? And so it goes up into the atmosphere, and it leaves the salt behind. So that, 97% of the water being ocean water is fine. It still supplies us with H2O into the atmosphere, okay? We also get evaporation through leaves, and that's known as transpiration. The plants draw water out of the ground through their roots, and that water actually comes out of their leaves as water vapor and goes back into the environment, okay? So the first step is evaporation. Now that water vapor in the atmosphere eventually recondenses back into tiny liquid droplets of water and forms clouds, okay? If you can see it, it's a liquid water. We'll talk a lot more about that in eighth grade. And so we go from evaporation to condensation, okay, step 2. And then finally, as that liquid water condenses into big enough droplets, it becomes too heavy and it falls back to the earth as precipitation, okay? So that's step 3. And now that water is fresh. It's clean, fresh H2O. It's going into rivers and lakes, going back into the ocean, okay? But this is a cycle. So even though I'm saying like step 1, 2, and 3, it doesn't end there. It keeps going, okay? And it's a continual cycle. So this is why we don't run out of fresh water, okay? The precipitation is crazy. That's 20 trillion. There are 20 trillion liters of moisture that fall on the earth each day, just in the United States, okay? There's less of that in areas of drought, but because we're talking about the whole earth and the whole atmosphere together, it kind of helps balance out a little bit, although there are some areas that struggle to get enough water, okay? So precipitation is not just liquid water, though. It could be frozen water, snow, hail. Those are still considered precipitation, because then that melts and you've got that liquid fresh water, okay? All right, so when that water hits the ground, it's going to soak in, and that's known as percolating or percolation. And what that means is the water just kind of filters through the dirt, okay? So if you've got rain falling, it's going to soak through the dirt there and collect kind of down on the bottom here. And believe it or not, the soil actually cleans the water. It filters it and makes it very, very ready to drink, okay? That's known as percolate. The water table is the upper layer of water, okay? So as the water soaks into the ground, it collects in areas, and you might actually have a huge supply of water underground. The top level of that water is known as the water table, okay? And it's not in the same spot. You know, the water table could kind of slope down like that. It's totally different levels. Excuse me. Scientists refer to different zones of the ground when it comes to water. The zone of aeration is the top part, okay? That's where the filtration is happening, okay? It's very porous, there's a lot of space, but it's not full of water. And so if it rains, the water is going to soak through that, and it's not going to collect in that area. If you zoom in on it, you can see that there's air gaps between that, okay? That's the zone of aeration. Beneath that would be the zone of saturation. That's full of water, okay? And the water table, by definition, oh boy, there we go, is that layer right in between, okay? Aeration zone above, zone of saturation below, okay? But in between that, you get this little kind of upwards action of water, okay, known as the capillary fringe. And we'll talk about capillary movement in the next section. But the water kind of gets drawn back upwards a little bit. It doesn't go very far. And so right at the water table level, you get this little capillary fringe where the water kind of pushes up a little bit, okay? And then a spring, let me actually get blue here so it makes more sense. A spring is where the water table meets the surface, okay? So if the saturated zone is high enough that it actually fills this area and it can bubble out on the surface, that is clean, drinkable, fresh water that you can actually drink without worry, because it's that filtered water coming out to the surface. The water table has come up high enough to do that. You shouldn't drink water out of a river or a stream, even if it's fresh water, because you don't know what's upstream. There could be dead animals. Animals could be going to the bathroom in it. There's usually a lot of bacteria in rivers and streams, even if it's moving. Certainly, you don't want to drink water out of like a pond or like any still water, because it can collect larvae and get very stagnant and cause all kinds of problems, okay? But a spring is actually safe to drink because of that aeration, because of that percolating filtration of the water going through the ground, okay? So once the water gets into the ground, it kind of gets collected in these different areas, okay? But how does it get there? So we've got these two vocab words. One is permeable and one is impermeable, okay? Permeable means that the water is able to soak through. It's porous enough, it's open enough that water can actually flow through, okay? So think of pouring water into a cup of gravel. It's obviously going to go all the way through it. Sand is very permeable also, okay? Impermeable means it does not let the water pass, okay? Clay, you can have a layer of clay that is actually impermeable. There's no gaps, there's no spaces for the water to move through. It might be wet, but the water can't get through it. And then, of course, bedrock down here on the bottom, that's just solid like granite and stuff, and the water does not get through that, okay? So because of these different kinds of layers, we get different collections of water, okay? A perched water table, and I think I might have a picture of that on the next slide. I'm not sure. A perched water table is kind of like a floating water table. So if I had like a collection of water in here, it's under the surface, but beneath it is an impermeable layer. So it can't soak down into the water beneath it. The water beneath it is coming from a different source. Okay. That's just known as a perched water table. It's like a separate collection of water. Okay. Our main collection of water underground in groundwater is known as an aquifer. Okay. And this is basically an area of the rock stratus, of the rock layers, that allows water to collect, and it actually it can make the water flow with the assistance of gravity. Okay. If somebody is to sink a well, let me get a different color here. What they're doing is they're drilling a well down into the ground, and they're drilling it down below the top of the water table. And then they can pump that water up, and it's fresh water and it's drinkable. And a lot of houses, a lot of cabins, that's actually how they get their water. We in the city, we get our water from a city supply, and it comes from pipes at a different location. But a lot of homes actually have a well on their property. And what that's doing is it's digging down into that aquifer. Okay. Now, if you don't dig deep enough, okay, or if the water table lowers, because seasonally the water table will change, you could run out of water. Okay, it can be kind of a problem. Okay, but these aquifers are these collection of waters. Okay, now if you get an aquifer that's kind of on this slant right here, and this is what's known as a confined aquifer. There's nowhere else for this water to go. What it does is it pressurizes the water, and this is known as an artesian well. And so the water actually pumps up on its own. You don't need any kind of mechanism to do that, because it's like a volcano. The magma needs to get out, just like this water needs to get out, because it's pressurized. So an artesian well is just a pressurized well because of gravity. Okay. All right. So groundwater can move. We just talked about a well. A well is dug down to access that groundwater. You can see a nice picture of a well right there. The cone of depression happens because the water is being pumped out. So the water is going up in that direction, and it's going to deplete the water in this area first. Okay, that's a cone of depression. Well, because of gravity, the water is going to kind of flow in this area to fill that in. And that's good for that well owner, but it might actually take water away from neighboring wells. Okay, it might actually cause the water to flow away from somewhere else it needs to be. Okay. So we also need to be able to recharge these areas. A recharging zone is an area on the surface that's allowing the groundwater to get in. And it might simply be because of rain hitting the ground and then soaking back into the water, the saturated zone there. The water table, or the saturated zone, the aquifers, can be fed by lakes and streams also. If you think about the ground underneath a lake, some of that water is going to be soaking in. And so some of that water is actually soaking into an underground water, aquifer. And then the water cycle is replenishing the lake with rain. So it's just all this continual taking water out and putting water back through that water cycle. Okay. Go get a drink of water and then turn off the faucet. All right.